Welcome to Educator.com. Continuing on with our discussion of radical expressions and equations, in today's lesson we're going to start learning about performing operations with radical expressions. Beginning with adding and subtracting radical expressions. It's actually very straightforward. In order to add or subtract, combine like radicals. It's important to understand this definition. Like radicals are those with the same radicands. For example, 4 square root of 3 plus 2 square root of 3. The radicand here is 3, and here it's 3. So whatever's under the radical sign we call as the radicand, and if those are the same, you can add. It's important to remember that you should simplify radicals before you add or subtract them. We talked in the previous lesson about how to simplify, eliminating radicals in the denominator, fractions under the radical, and making sure that the radicand does not contain any perfect squares. So in this example, I see that I already have simplest form. I can't simplify the square root of 3 any farther. The next thing I'm going to use to add is I'm going to keep in mind the distributive property. Recall that the distributive property says that a times the square root, or a times b plus c equals ab plus cd. Here, when I'm adding these, let's bring this down here, I'm actually going to be going from right to left and factoring out this common factor to give me 4 plus 2 times the square root of 3, which equals 6 square root 3. Okay. Now, this is the step in between here and here. This is what's really happening. But eventually, when you get comfortable with this, you'll just realize that you can go ahead and add these two, and what's outside the radical, and then bring the radical next to it. What you're really doing is using the distributive property. But again, you don't always have to write each step out, just as you're getting comfortable with it. Okay, taking another example. 6 square root of 32 minus 3 square root of 18. Remember that simplify radicals before adding or subtracting them. And here's why. I look at this and I might say, okay, there is nothing that I can do with this. I can't subtract them because they're not like radicals. However, that's not actually correct, because if you look at this, 32 factors out to 16 times 2. 18 factors out to 9 times 2. Using the product property, I can get this, moving my perfect squares by themselves under the radical. And then I'm going to take the square root of 16. That's going to give me 6 times 4, radical 2, minus 3. The square root of 9 is 3, radical 2. Okay, let's come up here with this. 6 times 4 is 24, radical 2, minus 9, radical 2. Therefore, I just say 24 minus 9, using the distributive property. So I pull out my common factor of square root of 2. 24 minus 9 is 15, radical 2. If I had not simplified first, I might have just said, okay, stop here, nothing I can do. When there actually is. I can end up with this, which is a much simpler expression. Multiplying radical expressions. So let's talk about multiplying two binomial expressions that involve radicals. In order to do this, you're going to use the same techniques that you've learned for multiplying general binomials. For multiplication, you should simplify the terms after multiplying. For example, if you are given 2 square root of 3 plus square root of 2 and asked to multiply that times the square root of 3 plus 2 square root of 5, This does look messy, but all you have to do is use FOIL, just like you did with other binomials. So I multiply out the first terms. 2 radical 3 times radical 3, plus the outer two terms. 2 radical 3 times 2 radical 5, plus the inner terms, which is radical 2 times radical 3, and then finally the last terms. Square root of 2 times 2 radical 5. Okay, making this a little bit simpler. 2 times 2 is 4. So that's going to give me 4 times radical 3 times radical 5 plus radical 2 times radical 3 plus 2 times radical 2 times radical 5. Then I'm going to use the product property. Remember that the product property tells me that the square root of AB equals square root of A times the square root of B. Okay, multiplying this out, remember also that a radical times itself is the radicand. So this is going to be 4. So I'm using the product property. I'm going from right to left this time. Plus radical 2 times 3 plus radical 2, 2 radical 2 times 5. Okay, now it's just some arithmetic. 2 times 3 is 6 plus 4 square root of 15 plus the square root of 6 plus 2 the square root of 10. Now I'm looking at this and I see that I really can't go any farther because there are no perfect squares in here for me to pull out. And since these are not like radicals, I can't add them. I multiplied it out and this is as far as I can get. Okay, let's apply these concepts to the examples. Well, looking here, we're supposed to simplify before adding. So simplify and then add and subtract, like radicals. I'm looking and I do have 2 sets of like radicals, so I'm going to go ahead and group those to make it easier to work with. So I have 5, the square root of 3, and I have 6, square root of 3, plus negative 2, square root of 11, plus 8, square root of 11. Now I'm going to use the distributive property, as I mentioned before, and that will give me 5 plus 6, pulling out this common factor, the square root of 3, plus negative 2 plus 8 times the square root of 11. So I'm just going to go ahead and add. This is 11 square root of 3 plus 6 square root of 11. And I'm looking at this, making sure it's in simplest form. I checked that I had simplified before, but I'm just going to double check down here, and there's really nothing else I can do. There are no perfect squares under here. There's nothing else that needs to be done. So all I did is group the like radicals, and then use the distributive property, and then performed addition or subtraction. Okay, this example looks a little bit more complex, but you need to keep in mind that we have to simplify first. Because at first I look at this and I say, okay, there's no like radicals. But I can't really say that until I have them in simplest form. So let's go ahead and simplify. Finding my perfect squares. Well, for 8, that's the product of 4 times 2. And then an x is right here. Minus 3. 18 contains a factor that is a perfect square. It contains 9. Now I've got 6 radical 72x, and 72 is actually the product of 36 times 2. And then 98 factors out to 49 times 2. And you might need to take some time on this, take 98, factor it out until you've figured out what your perfect square, if you have perfect squares, what they are. So take your time on this step because it's very important. Now, rewriting this so that I have the perfect square using the product property. Having my perfect squares as part of this first radical and the other factors as part of the second radical. So this is going to give me radical 4 times radical 2x minus 3. Radical 9 is my perfect square times radical 2x plus 6, perfect square of 36, times radical 2x, and we see a pattern starting to emerge with the 2x, radical 49 times 2x. I'm going to go ahead and take the square roots of all the perfect squares to get 2 times 2, here 3, and then square root of 9 is 3, 6 times 6, and let's see, 8, and that's 7 times 7 would be 49, so 7 is the square root. Go ahead and multiply this out to simplify it further. Six times 6, that's 36, and then negative 56. Okay, now that I've done all this simplification, I can see that I do have like radicals, and I can add those. So I'm going to use the distributive property to get 4 minus 9 plus 36 minus 56 times the square root of x, 2x. This is negative 5 plus 36 gives 31 minus 56 is negative 25 2x. This is the solution for the simplest form. And as you can see, this is far simpler than the first one. The key was first simplifying the radicals by writing them as perfect squares times their other factors, and then taking the square root of each of those perfect squares and noting that what was left behind were like radicals. Okay, in example 3, we're asked to multiply, and this is the square of a binomial. So we're asked to square a binomial, and just thinking back without involving the radicals, it's a difference squared. It's the difference of two terms, and it's the square of that difference. So we have the square of a difference, which equals a squared minus 2ab plus b squared. So if I recall this, then I just look over here and I say, okay, a equals 3, square root of 2, and b equals 6, square root of 3. Okay, then knowing this, I can just go ahead and apply this formula. So I'm going to have a squared minus 2ab plus b squared. And if you didn't remember that, that's fine. You could have always rewritten this as 3 radical 2 minus 6 radical 3 times itself, and then used FOIL and gone through and multiplied out each. So a squared, this gives me 3, the square root of 2, and all of that is going to be squared, minus 2ab, so that's 2 times 3 radical 2 times 6 radical 3 plus b squared. Okay, now 3 times 3 is 9, so 3 squared is 9, and the square root of 2 times itself is the radicand 2, so that gives me 2 minus, now I need to go ahead and multiply out 2 times 3, which is 6, radical 2, times 6 radical 3, plus 6 times 6 is 36, radical 3 squared just gives me 3. Okay, so 9 times 2 is 18, 6, this is minus 6 times 6, that's 36, radical 2, radical 3, plus 36 times 3, which is actually 108, using the product property to get 2 times 3. And that gives me 18 minus 36 radical 6 plus 108. So I'm going to take 18 plus 108 to get 126 minus 36 square root of 6. Okay, so again, I simplified by multiplying this binomial. It's a difference squared. So this is a square of a difference. And I used the formula for that in order to rewrite this as the following. Once I did that, I recalled that a radical times itself is the radicand. I found my squares of each term here, multiplied these two out, and then just went on and simplified. I got down to this point and I cannot simplify any further. So it's 126 minus 36 square root of 6. Okay, in the last example, we're again asked to multiply a binomial, but there's no special formulas for this one. I just have to go ahead and use FOIL, multiplying first, outer, inner, and then last. So that's going to give me the first term, 2 square root of 8, times the other first term, 4 square root of 12, plus the outer two terms, 2 radical 8 times 5 radical 15, the inner terms, plus negative 3 radical 6 times 4 radical 12, and then finally the last terms, negative 3 radical 6 and 5 radical 15. Okay, now I just need to go on and do some multiplication and some simplification. 2 times 4 is 8. Square root of 8 times the square root of 12, plus 2 times 5 is going to give me 10, times the square root of 8 times the square root of 15, plus, this is going to be negative 12 times the square root of 6 times the square root of 12, plus negative 3 times 5, so it's negative 15, square root of 6 times the square root of 15. So this is a lot to keep track of. Just be very careful and double check along the way. So here I'm going to use the product property to rewrite this as 8 times the square root of 8 times 12, plus 10 times the square root of 8 times 15. To make this simpler, instead of saying plus a negative 12, I'm just going to say minus 12, square root of 6 times 12, minus 15, square root of 6 times 15. Okay, doing some multiplication. 8 times 12 is 96, plus 10. 8 times 15 is 120. 6 times 12 is 72. And 6 times 15 is 90. Now, once you're done multiplying, simplify. So remember, multiply, then simplify. So let's factor out the perfect squares. So I definitely have some perfect squares here. Remember that 96 is the product of 16 and 6. 120 can be rewritten as the product of 10 and, 4 and 30, the product of 4 and 30. So this is 10 radical 4 times 30. 72 is the product of 36 times 2. And then 90 is the product of 9 times 10. Factor out these perfect squares, or not factor out, take the square root of the perfect squares. So that's going to give me 8 times 4, because the square root of 16 is 4. What's left behind is a radical 6. Square root of 4 is 2. Left behind, square root of 30. Made a little error here. That is actually 12, not 120. So that is 12. Again, important to check back. So I have 12 times 6, square root of 2. And then square root of 9 is 3, and that leaves square root of 10 behind. So just kind of double checking over to make sure that no errors were made. Okay, now I'm going to go ahead and multiply these out. 8 times 4, that's 32. 10 times 2 is 20. The radicals are just staying the same. 12 times 6 gives me 72. And 15 times 3 is 45. Now I'm going to stop and see if I can simplify this any further. And I look and I don't have any perfect squares that I can pull out from under the radical. And I don't have any like radicals. If I did have like radicals, I would add or subtract those, but I don't. So this is as far as I can go. So in order to simplify this, I had to use FOIL, and I multiplied my outer terms right here, the inner terms, and the last terms. And then I used the product property to rewrite these as follows. Went ahead and multiplied, and then when I finished my multiplying, then I simplified, starting at this step, by factoring out the perfect squares, and then taking the square roots of each of those using the product property. Once that was done, I just had to multiply what was outside each radical to get my final answer. And that concludes this lesson for Educator.com.